That's good. I see people coming on.
All right, well, Anne has given me the green light to get going. So since we are now just after the hour and folks have had a few minutes to get into the room after opening it up, I would like to welcome everybody today. So this webinar is sponsored by the Teaching Statistics and Health Sciences section of the American Statistical Association. And my name is Lila Poisson, and I'm the current section chair. I'd like to welcome you to this webinar. And if you're not a current member of the section, I'd like to encourage you to consider joining. We host a number of activities throughout the year and work to build a community of statistical educators who primarily work in the health sciences setting. We also host the TSHS portal, so if you're in need of real-world data for your courses, please head on over there. For more information about our section, please visit our blog and website. We also encourage you to join. We also encourage you to join our section as you are looking at your renewal for this year. Okay, so this webinar format this afternoon, we'll have our speaker presenting slides and saving some time for discussion and questions at the end. All attendees are going to be muted during the presentation. If you have questions, we ask that you please use the Q&A button at the bottom of your screen to enter that question. Our speaker is glad to answer questions during the presentation or wait till the end of presentation. We ask that you do not use the chat button since no one will be monitoring the chat room. So again, please use the Q&A button to ask questions of the speaker. So today we welcome Doug Landsittel. He's a faculty member at the University of Pittsburgh, and Doug will become co-chair of the TSHS research portal in January when Anne, who is hosting today here in this webinar, will become the chair of the TSHS section. So today, Doug will be sharing material that he had shared with a few of you at the JSM Roundtable this summer. And since that roundtable sessions were a little bit funny, doing them virtually, we invited him to come and share this information more broadly in a webinar. So we appreciate him being willing to do that. So Doug's presentation is Challenges in and Educational Strategies for Teaching Causal Inference in the Health Sciences. Thank you, Doug.
Okay, thank you, Layla. I appreciate you having me speak to the group on this webinar. So as she mentioned, my name's Doug Landsittel. Just to tell you a little about myself and my lab. I'm a professor in biomedical informatics, but hiding out as the lone statistician in the department. And I've taught a number of courses that are relevant to this discussion, particularly in comparative effectiveness research and patient-centered outcomes research over the last 10 years. And I'm the core faculty and other groups involved in this area, like our Comparative Effectiveness Research Core, Institute for Clinical Research Education, and I direct a network of minority and Hispanic serving institutions focused on patient-centered outcomes research. I do a lot of work with collaborating with our health system, and also had some grants on developing educational resources. So it's an area of interest to me, definitely. So first, let me start with the big picture. This is the section on teaching statistics in the health sciences. So obviously, teaching statistics in the health sciences could involve a number of different audiences. So that might be focused on training statisticians, training epidemiologists, clinical researchers, biomedical researchers, other types of trainees. There are also obviously a lot of topics that one could cover in those types of courses, anywhere from foundational issues, which I think everyone should have, on concepts and designs, and also the underlying mathematics for the statistics that we're looking at. Also, one of the things that comes up for those of you that work in health sciences and clinical and biomedical research, as you know, is what I'll call discipline-specific advanced methods. So those that are, say, in the lab may focus on clustering methods. Things like omics research have their own set of methods. And more broadly, I think the area of causal inference is coming up more and more in teaching statistics in the health sciences. So it's really these two areas that I want to focus on, the intersection of these two. And this is somewhat just because they're of interest to me, but also I think that they're very much kind of exploding now for a number of different reasons. So I'll focus on clinical researchers and focus on causal inference methods, which I think apply very broadly across a lot of areas of clinical research. So first, in case you're not convinced, I hope to convince you that causal inference is really critical to clinical research. So we may be looking at efficacy of interventions and medical treatments, asking, is there a causal effect? So it's rarely of interest to say, well, this intervention is related or associated to the outcome. Usually, if we're talking about interventions, medical treatments, we really do need to talk about a causal effect. Also, there's the area of comparative effectiveness research, or CER, which you could think of as what works best for whom and what circumstances. So the idea of CER is you're taking at least two or more established methods that have been shown to be efficacious. So they work some of the time for some of the people, and now we want to do a head-to-head comparison of the two. So this also necessitates looking at causal inferences. Again, associations are rarely of interest in CER. Another area of interest where causal inference is really critical is with health disparities research. So a major challenge in health disparities research is, are we evaluating or detecting associations where maybe race is a surrogate for something else? Or are we really focusing on causal relationships? And here the associations may be of interest, but certainly looking at causal relationships between race and clinical outcomes is very important. Another area that's come up, which NIH has really focused on the last few years, is evaluating sex as a biological variable. So the idea that, and this is now formally part of their review process, not in scoring, but reviewers always have to comment on this, is whether the application not just has males and females in the data set, but specifically focuses on sex as a biological variable. So that might be looking at interactions, it might be looking at whether sex is some part of some causal mechanism. Okay. And oftentimes in clinical research, we use randomization to eliminate confounding and make statements about causal inference. But this really comes as a cost. As all of you know, of course, Randomized studies are very challenging in terms of they take many years to conduct. It may not be feasible. The results may be outdated by the time they're available. It may not be ethical to randomize. So there's lots of reasons that randomization is very problematic, and sometimes it's impossible to do for certain research questions. Okay? So hopefully you buy the fact that causal inference is really critical to clinical research. So then you might say, okay, well, what's the big deal? So you teach causal inference to clinical researchers. So what? We all teach lots of things to our, different subsets of trainees. Well, it's actually somewhat controversial. I had a project, a contract funded by the Patient-Centered Outcomes Research Institute a few years ago. And in looking at the reviews, I was actually surprised. We had proposed, and we did develop, and I'll mention it here today when we go to my website, we said we wanted to develop educational resources to facilitate researchers' ability to conduct well-described causal inference methods and valid methods. And I did get, at least from one of the reviewers, a lot of pushback, basically saying that, this is too complicated for non-statisticians. You really should have at least a master's level or maybe doctoral training in statistics before you should ever fool around with causal inference methods. And what we may be doing is giving people just enough knowledge to be dangerous. But what we need here is not to try to facilitate education and causal inference, but this reviewer argued that we should just hand it over to the statistician and not get things all screwed up by trying to teach clinical researchers anything causal inference, or at least these kinds of methods. So while I appreciated that perspective, I have a bit of a different perspective here. So my teaching perspective is, first of all, say I've taught two sets of courses on comparative effectiveness research. One was an AHRQ-funded online course that we taught as part of a R25 funded effort. And that I did for about 5 years, and we're still continuing collaborations with a group of nationally representative minority serving and Hispanic serving institutions. And that's called the Expanding National Capacity and PCOR Through Training Network. And I'll point to some of that on my website here before we finish. Another is what I called an in-person class. It's not really in person this year, but otherwise in person in our Institute for Clinical Research Education. So the ICRE focuses on training clinical researchers we generally use shorter course modules, and there's a lot of flexibility in terms of when they take courses, what they take, a lot of 1 credit, 2 credit modules. This is a 2 credit course that we have. And so I've taught this for about 10 years. And it's mostly across both of these programs has been mostly master's, MS, MD students, a number of postdoc fellows, and also faculty spanning from junior faculty to mid-range and even some senior full professors in the training courses. And their areas of research, their statistical skill sets are very, very diverse. So this makes it very challenging to jump into issues like causal inference that are very complicated from the statistics and epidemiological process or perspective, which I'll get into in just a few minutes. And so what we did in these courses is our goal was not for them to do problems with statistical software, but rather to develop a 3 to 5 page concept proposal in comparative effectiveness research. So they got to pick the topic of interest, which really made them invested in the project. They got to specify the research question, the study design, and we just worked through each of these issues, from your research question to the design, which could be either randomized or it could be observational or quasi-experimental. We also talked about stakeholder engagement methods, detecting and methods for heterogeneity of treatment effects, And we went into some of the basics of causal inference. So it's kind of teaching this and working on this effort with our NAC course. That's my perspective on being interested in causal inference from the educational and research collaboration perspective. So my goal really in these courses, I think you could best summarize by saying, is what I sought to do is build an appreciation of causal inference methods. Not really so much to teach them everything about causal inference. That would be absolutely impossible. We would need another degree program for that, and we'd need a lot more prerequisite requirements. So the perspective or the approach that I take is really to emphasize the significance of causal inference and the complexity of causal inference methods. So I think sometimes if they come out of the course thinking, you know, this is really, we're not going to be able to meet the assumptions of these methods. It's too complicated. We don't really have the data to address confounding, et cetera. And they decide this is something we really can't get into. I consider that a win in terms of the quality of research coming out. So in the method or in the courses, we also describe not just methods, but some of the concepts that underlie causal inference methods, or at least a subset of them that are specific to statistics and epidemiology. So my colleagues in computer science and philosophy have a different idea of what causal inference is. But from my perspective, we talk about concepts like potential outcomes, specifying a target trial, developing a causal roadmap, and I'll step through each of these very briefly in case you're not familiar with the terms. Developing methods that pseudo-randomize observational methods, and then saying a little bit about the statistical methods like propensity score-based methods, and really emphasizing the assumptions and the challenges, and also some of the underlying mathematics. So I see a lot of debate on the discussions with teaching statistics to non-statistical audiences. And one of the things I've heard many times is just stay away from the mathematics and formulas, which I understand that perspective. I like to take a little different perspective and actually get into the math, but do it in a way that I think is understandable to them. So I'll give you an example there. So also, I like to give them some insight on where to look for more. So the idea is, well, we can't really get into all these methods. I can talk about these steps from your research question to potential outcomes to target trial, et cetera, but I can't really get into them other than raising awareness of what they are. So rather than just leave them hanging, I've spent a lot of the last 5 years of my career working with people in my lab, especially my instructional designer, Kristen Croft, and some of my statisticians on developing website resources. And so I'll mention a few of those. So that way, I don't say, hey, this is too complicated for you. You know, trust me, I'm the statistician, stay away from this stuff. But rather, we build up the ideas that by the end, they have an appreciation of the complexity. And then I say, you know what? You need to be collaborating with statisticians and epidemiologists to work in these areas, but here's some resources so you can get some more insight. And what I also try to do is introduce flexibility through a project proposal format. So the idea is they write this 3 to 5 page project proposal. So you can kind of think of it like an R03, R21 kind of application, except it may be a more grandiose R01 type idea, but just a short proposal. And in that way, it really ties them to areas that they're interested in. And I've had multiple trainees from these courses get internal and external funding directly related to the project proposal that they did in our course. So I think that's also very rewarding from my perspective too. Okay, so let me just, next 3 slides, in case you're not sort of aware of the different frameworks for causal inference, I want to step through 3 ideas: potential outcomes, the target trial, and causal roadmap. So these are very well-established issues or frameworks, but I think they're important. So we do spend time, and what I've done in the courses is I try to introduce this early in the class and repeat it over and over throughout the course. So I tell them at the beginning, if by the end of the course you're thinking, oh, potential outcomes again, we already talked about this, that's the idea. So I mention it early when we talk about their research question of how it relates to whether they're doing a trial or observational study. And then when we talk about statistical study design, I mention it again and how that relates to study design. And then when we introduce propensity score-based methods, we talk about it again. So the idea of potential outcomes, very briefly, is that the subject, we'll call it subject I, call them subject I, is on a particular treatment or intervention. And it's that treatment or intervention that leads to some outcome. So this is where I try to introduce a little bit of mathematics to them, which is going to sound very simple, but I think is very useful. So it's at this point I say a big part of statistics, I think, in terms of understanding the underlying theory is just understanding the notation to start. So I just note to them that, okay, this subscript, sub I, refers to the subject I. So when you see sub I, you're talking about this subject I here. Similarly, the superscript A refers to treatment A. So when you see Y sub I of A, you know that's an outcome for a specific subject that's indexed by by I, and it's that outcomes on treatment A. And then we have the same subject. So the notation here, the I here is the same as the I here. So it's the same subject. So we're going to pretend this is like parallel universes where everything is the same. It's the same subject, except they receive treatment B, and we observe outcome Y sub I of B. So there's the same notation, except they're on treatment or intervention B instead of A. And we call these the potential outcomes, where one is observed and another one is counterfactual or not observed. And then we can define the causal effect, both in terms of the individual causal effect, which usually we can't ever estimate this unless it's something very specific, like a crossover trial and it's a certain condition and you have the washout period, etc. But in general, we either observe this or we observe that. But if we knew both of them, the individual causal effect would be either the difference or the ratio or the risk ratio, some other contrast or function of that. So this gives the mathematical notation that we can step through in just a few minutes and give them some idea of what we're actually trying to estimate. And the idea is we don't usually estimate this, but rather we estimate what the expected value of that would be over some population, the average causal effect or average treatment effect. And then I use that to step through other ideas like the average treatment effect among the treated. And we talk about differences between randomization, where we flip a coin to say who's on A and who's on B, versus observation, where there's all these different factors that affect who's on A, who's on B, and how that relates to whether this causal effect is biased or unbiased. So this description of potential outcomes, I think, leads into a lot of key issues with causal effects. I also like to introduce the idea by Hernan and Robbins and others with the target trial. So the idea of the target trial is that oftentimes we think of observational data from the perspective of, well, we have the data, let's just throw it all into our model and analyze it. There's no need to restrict it because we've got it all, we observed it. Whereas Hernan argues instead that we have this observational data set and we need to look at the specific research question. And that research question leads to a hypothetical trial where we have certain inclusion and exclusion criteria. We have a causal contrast of interest. We have a quantity of interest that we estimate, the estimand, and then you can emulate a hypothetical trial. And there's a lot of other people that have talked about this idea too and worked on. There's some of the funded research by the CORI, the Patient-Centered Outcomes Research Institute, from people at Brown University and others that looks at the process of emulating a target trial and some results. Okay. So, but the idea is that we should not look at observational data as just the total available data set we throw into some kind of algorithm, but instead we should define our research question and have a well-defined causal question. So this is really another part that I think philosophically just has to be part of teaching anything with causal inference. And the third and final one that I'll mention that I think is really important for our conceptual framework is the causal roadmap proposed by Pearson and Van der Laan in a number of papers, which I think goes together with the ideas of potential outcomes and the target trial. So what they say is that we should first describe knowledge through a causal model or causal graph. And I have the trainees in the courses through a workbook that I've developed, and I'll show you the link to the workbook, actually draw out the causal model or causal graph. So they may start with more of a conceptual model is what they're more used to, but then trying to outline what are the main confounders, what are the instruments, what are the effect modifiers, mediators, etc. Then in the causal roadmap, we say what data do we have and how does it relate to our causal model or where is it lacking? Then we can define the target causal quantity in terms of a function of the potential outcomes and assess a feasibility of our assumptions. And then, only then, can we specify a statistical model and the associated quantity that we're trying to estimate. And then go ahead and conduct the analysis, and using all of those steps from the beginning of our causal graph through our analysis results, try to interpret the results relative to a causal effect. And the thing I want to point out here is the part that many people think about as causal inference from the statistics, epidemiology, they just think of the model. They think of, oh, I'm going to do propensity scores. As a frequent reviewer, I see that in applications all the time, where their statistics section says, we're going to do propensity scores. Like propensity scores is this all-inclusive 2 words that tells you exactly what you're going to do. When in fact, propensity score-based methods are a set of methods that are one part of this analysis. So the part we usually think of as statistical methods conducting the analysis is just a small part of the process. Okay. So we also cover some other topics that I think are important. So I think it's good to give them an example of what a statistical model might be that attempts to emulate a randomized trial. So I like to talk about propensity score-based methods, not because they're the begin-all, end-all of causal inference methods, but I find them very intuitive, saying we think there's some mechanism that is predicting which treatment a person receives. We're going to model that mechanism. We're going to get a prediction from that model, and we're going to use the individual predictions to basically shift around our population or our sample, either through matching, weighting, stratifying, or some other kind of combination of methods and robust approaches to pseudo-randomize, basically. And then we're going to apply standard methods that we call the outcomes model. So I think it's a very intuitive process that says a lot about what we're trying to do with causal inference in observational settings. I also like to introduce instrumental variables, since they're just a inherently different type of process that has different assumptions. And I also like to think about the differences between point and sustained or time varying interventions, and mention a few of the methods like marginal structural models, G methods. I don't have time to get into any of them, and I think it would be very difficult to do in the audience that I'm working with, but I think it's good to make them aware of it, and then also make them aware of sensitivity analyses. And I like also to think of causal, oops, I forgot to add the reference there, sorry. I also like to think of causal inference methods as just an extension of standard methods. You know, maybe it's something like using a propensity and matching and weighting, just like we use matching and weighting in epidemiology or stratifying. Maybe it's something that's more of a standardization kind of procedure as we use with G methods, something to that effect. So just a couple more perspectives, and then I'm going to get to the website that we have and then stop early for questions. So my personal view is that in teaching statistics in the health sciences specific to clinical researchers and to in the area of causal inference, again, just in the area that I'm interested in, I'm not trying to make a blanket all-inclusive statement, is that working through with the trainees to conduct all the analyses is counterproductive. One, I don't think that's really where their efforts should be focused. I think where it should be focused is on just getting a knowledge of where these methods are applicable, what their limitations are, so that when they work with statisticians, they work with epidemiologists, they have some shared knowledge beginning in the process. And I think as a statistician who spends most of my time on collaborations, I think that that's very beneficial and really makes the process more efficient. I think also that it's important to realize that we can't take a very narrow, biased view of, well, they're clinical researchers, they're non-statisticians, and that means they know this and they don't know this. Instead, I would point out that many of my collaborators and my colleague and I at Pitt have talked about this a number of times, is that many of our collaborators in clinical research have some of the strongest statistical and epidemiologic skills of any of the trainees we've worked with, including in more formal statistical or biostatistical programs. It's just there's a lot of variability. So I try to keep an open mind and really accept my role as the educator and collaborator, where my role can vary differently across projects. I'm working with a colleague in our ENACT program now who is very interested in using propensity score-based methods, and he's really gotten interested in running all these analyses, mostly himself, but with help from a nurse statistician at his institution in Hawaii, and also in collaboration discussions with me. And so the project, it works very well. There's other collaborators where that type of approach would not work well. So I try to have different frameworks that we think about. And as I said, kind of avoid a judgmental role and a predefined role, but rather just sort of openly present concerns and limitations about methods as we go. And then as an educator, I think it's really important for me to emphasize design and encourage things like causal graphs that may not be what they're used to doing, but I think are very important. So to get them to think about the underlying relationships rather than taking a kitchen sink approach of like, I'm going to take a bowl of spaghetti and throw it against the wall and see what sticks. So I also spend substantial time reinforcing those points. I don't stay away from the underlying mathematics. So just like I sketched out just very briefly on the potential outcome slide, I do try to jump into some notational issues just from the perspective of describing very intuitively, what does the notation mean, and why is it different when I see one set of notation versus another notation, and then really get into differences in causal estimate. So in the Corey project, I had the chance to work with a lot of really well-established researchers in causal inference. And I remember as part of our advisory committee, Sharon Lee Storman from Harvard was talking about, she said, you know, if you could just get people to see that it's not always an apples to apples comparison, when they're looking at one method versus the other, they may be looking at different causal estimates. So it may not be one method is better, one method is worse, but they're different. And I think that mistake is made a lot. I've seen a lot of papers that say, well, here's, excuse me, here's what the randomized trial got, here's what instrumental variables got, here's what regression got, here's what propensity score matching got. And all of those methods have different causal estimates. So it's very problematic to try and make different comparisons. And I do try to point this out as a key point to trainees. And I also try to point out the assumptions that maybe we don't get into all the details, but intuitive explanations about what does positivity mean? What does the Ferrant unit treatment value assumption mean in independence of individual potential outcomes, and then also conditional independence of the treatment effect conditioning on different confounders. So I do try to, I think that's part of my role as an educator, is to walk through those things, just make sure they realize that they exist. And I think if they realize they exist and they spend a little time thinking about it relative to their clinical problem, it could really, you know, stick with them quite well. So I'm going to jump to my lab website, and then I'll come back for comments. My email is here, dpl12@pitt.edu, and the website, one benefit of having a less than common last name is you could just throw your last name and get a unique website. So it's just landsittelLab.pitt.edu. So let me go to the website, and I just want to show you a few of the resources we've developed here. Maybe before I do that, were there any questions? Layla, I don't know if you were monitoring that, if anything came through. I'm not very good at multitasking.
No, I've been monitoring it for you. Folks are quiet at the moment. I know I'm taking notes, so perhaps others are as well. So.
Okay, well, I'll go through the website, and I will leave I'll leave time for questions here if things arise. Great. So I just wanted to point out a bit of self-promotion here. The website that we've developed, which I'm really trying to make kind of a go-to place for educational resources in the area of patient-centered outcomes research. So patient-centered outcomes research, in case you're not familiar with it, basically is about patient-centered comparative effectiveness. So the idea is for a given, and this is the definition, or paraphrasing the definition from the Patient-Centered Outcomes Research Institute, which just got reauthorized for another 10 years recently, which was very exciting. If you're not familiar with that group, I'd be happy to talk about it offline or questions here. But anyway, they define PCOR as basically answering questions about healthcare and medical treatments in a way where they answer 4 questions, or research that answers 4 questions. So one is an issue of prognosis. So for me, myself, everything about me, my preferences, my situation, and what can I expect will happen? So prognosis. The second one is what are the options out there as far as treatment? And then 3 and 4, I can never remember individually, but 3 and 4 relate to what can the healthcare system and my physician Oh, so 3 is actually what can I do to improve possible outcomes with treatments? And then 4 is what can my healthcare provider and the healthcare system do to improve outcomes? So it's an idea of what can I expect, then what are the decisional dilemmas, and then what are the possible treatments and compare effectiveness of those treatments relative to patient-centered outcomes. So we have developed a number of educational resources. So I'm just going to go to that tab and just spam that. So if you go under educational resources, there's an overall overview here. And again, my instructional designer, Kristen Croft, has done all the hard work on this to make it incredibly well organized, I think. And so we have a few things on here. There's the course that we developed, and I'd like to spend a few minutes on that for the AHRQ funded grant that I mentioned. There's another one which was funded by PCORI through a contract, which was the decision tool for causal inference and observational data analysis methods in compare effectiveness research, or DECODE CER. There's another tool that was also sort of a overlap between these two. It's some of the same information on DECODE CER, but it focuses more on propensity score-based methods, and it's more of this online self-guided format. And that was finalized through funding by a supplement to our T15 training in biomedical informatics. I also have a link here, I'll get to that now, for teaching statistics in health sciences. So this is our landing page. It's on our website, but from here you could go to either the website, the home website for the section. So there's that link. And then there's also a link to the web portal that Layla mentioned that Anne runs, and I will be co-directing with Carol from Amherst beginning next year. And so from this web portal, you could get to different resources. I use this obstetrics and periodontal therapy as an example of my statistics courses. It has a lot of interesting components to it. So just to mention that. Going back to the educational resources tab, I also have a link to Liz Stewart's webpage because I think she does such a great job at pulling together so many software packages. So if you're interested in propensity score-based methods, sensitivity analyses, and so on, you can link to her page, which just has pretty much everything you could want as far as that goes. So let me just go back to, for a moment, to some of these other resources. So let me go to the DECODE CER tool first. We developed this through a PCORI contract, as is listed here in the acknowledgement. The second link here just has some different information you can find on the PCORI website about it. But this has the tool that we created. And basically what you can see is it's a set of Google Slides which just links out to more and more detailed information. And we are working on a second version of this. This is the version, I'll keep this version since this is what we submitted to PCORI. So what you could see is it's kind of like a little mini booklet that has links that you can either skip over if you know about them, or you can go into more detail. So if you look at this and you say, oh, this is for compare effectiveness research, well, I don't even know what that is, then you could go to a link, and we decide to link. We just link to a couple of things to get you the main points. We link to the IOM, or now the National Academy's book. So it has other links for different things. Sometimes the links are different websites. Sometimes they're a list of references. The second slide just kind of gives some direction on how to navigate this, which I'll walk through here, is on the third slide. This is the main slide that's kind of the overall framework. So the blue here, and I realize I should change these colors for It was since pointed out to me just in terms of anyone's colorblind is not a very good color combination, but so we'll change that next version. The blue slides or links are for general information from the research question, adequacy of the data, scope of this tool, causal graphs, etc. has different information. The green slides are more specific to propensity score-based methods, and then a few in purple here link to some information about instrumental variables. And then we have some other things that we did, and we're working on running other simulation studies and updating systematic reviews we did, and then also a little information about forming an analytical plan specific to this area. The two top gray circles take you back to the first two slides. So if you wanted to see about the research question, you'd click on that. It would take you to slide 4. And one thing I've learned with online education is you need to have everything formatted the same. So it just has a visual link, a short description, some background resources, and they're mostly all formatted this way. And then you could go back to the main tool. So I encourage you to look at that. I'm happy to talk about more. I do want to mention, I won't mention the propensity score class anymore. I do want to mention this online self-guide course for patient-centered outcomes research. We developed this through the grant funding, but I use it now for the, hopefully again, the future in-person class. So this is saved on Google Drive and has links to basically a textbook that we use. So the first document is a syllabus. So it has all the syllabus stuff like course format, etc. And then you can link to course modules. So if I want to learn a little bit more about, again, asking the research question, I go to the first module. And the module is formatted the same for all our modules. There's a little video introduction. I won't click on this, but we try and make it a little more personalized. So Kristen has developed some videos where if you clicked on this, it would be a video of her just saying, hey, welcome to our course. This is what it's about. Here's what you'll find in this module, this kind of thing. And then there are objectives of each module, and there are basically homework assignments where we decide we're not going to reinvent the wheel, but we're going to leverage what's out there. So we have links to different videos from either Ohio State, UC Davis, or Johns Hopkins created for PCORI. And we have additional reviews. So what I do for purposes of the class is there's so many videos out there. So you might say, you know what, Doug, I hate to burst your bubble, but there's all these videos out there. Is this really, you just put some links up there. So, so what? Well, anyone's trying to search through the web for information they need on patient-centered outcomes research will know that it's an insane task to try to do. So what I did is I pulled together a discrete number of videos that total about 1 to 2 hours in each module. So it's a doable thing for students to do from a Tuesday to a Thursday, because we have a Tuesday-Thursday class. And then what they do is we developed a workbook where they work through their research questions. So I'll go to the course workbook, and there's a link to different pages for each module. So this takes you, you could scroll up to the top. This takes you to the link here to the first module, asking the research question. And what we do is we just try to work through it one step at a time. So I found trying to work with trainees and say, here's all the things you need to worry about. Now, go ahead and write your abstract, or go ahead and write a 1-paragraph description of your research question. What happens is people freeze, they get writer's block, they get something together they're not happy about, they struggle with it, they get frustrated, and then halfway through the course, they say, I'm not happy with it, I want to start over. So what we do is just step through. So what I say is, thinking about your research, just write a few sentences about it. Now, and then I link it to the information that's out there. Now look at these questions. So first, these questions are just make sure it's well focused. Are you really going to apply for funding? Does this compare to interventions? because that's what the class is about, is comparative effectiveness. Are you interested in this? If not, modify your statements or your question. Then the next set takes the 5 characteristics of CER as explained by the Institutes of Medicine, now National Academies, and I just ask them to go through it yes or no. And then I say, well, did you answer no? If so, go back and modify your question. And I try to give them examples. Here are some good. So I took the question of, is radical prostatectomy a good treatment for men with prostate cancer? And I said, well, that's not a very good question. Let's improve it. And then I gave them a couple examples. And I said, looking at this and, just try to think about this as an example and then ask questions. Does it meet the definition of patient-centered outcomes research? If not, try to modify the question. And they go through the first workbook. It's pretty long. It's like 10 different questions. Most of them are shorter. And then what they work up to is take everything they did in that module and put it together in a paragraph. And at the end of the year, when they write their 3 to 5 page proposal, what they can do is just cut and paste a lot of these things out of their workbook. And I find it leads to a lot less frustration and a lot more productivity and efficiency. And what I do is I have them work together in peer groups to work through this. So this is some of the stuff we have under our educational resources. I mentioned the Expanding National Capacity and PCOR through Training Network, and we have a separate tab on that. If you happen to be calling or work with minority, Hispanic serving institutions, other institutions focused on health disparities, I'd love to talk with you about kind of joining our partnership. We've kind of morphed from our leadership circle to a steering committee that meets every few months, and we talk about manuscripts funding and other areas of interest. And then I've double referenced the course here. And we have, if you want to learn about, Kristen has pulled together different newsletters and highlights about. So for instance, we had a face-to-face meeting in Puerto Rico just in time, February 1st. If it had been another few weeks later, it'd been in trouble. But so she has a highlights from the meeting, a newsletter, just information about our group, the course, etc. Then there's a little more that's maybe less relevant to this seminar, but I'll just mention other groups where I collaborate with. We have some links again to just kind of tie together the research interests of our group. So I've left, as is usual, I talk longer than I intended to, but I still have left a little time if there are questions.
Okay, thank you, Doug. I'm just navigating here to try and open up the different screens. I want to remind folks that if you have questions, to please put those in the Q&A box. Again, this was originally designed to be a roundtable conversation. So we are, of course, eager to have some of that discussion. So I'm going to ask sort of a timely question, and I know that, and I'll come up on video here. I know that in the last several months, clinical researchers here at Henry Ford have been very interested in observational data, especially around the idea of COVID-19. And so I mean, it would have been fantastic to kind of pass them off to some of these processes and trainings, but have you seen an increased interest in causal modeling during this pandemic, or have you seen that some of your former trainees are feeling pretty well prepared to handle what they're getting?
Well, I think some of them definitely are, maybe not in the sense of just, jumping up and pulling up data and starting to run complex methods, although some of them, as I said, some of my collaborators who have gone through, I should mention the ENACT network. What we did is we, for 5 years, ran an online course, and we had experiential training of 22 people that spend a month in Pittsburgh. So I have, had follow up with them. I definitely, I'm not so sure from this group, but I work with groups. I work on a CDC Foundation grant on hospital surveillance of COVID. And that's a multi-site group, including a number of different institutions nationally. And they are very interested in, I've given a couple of talks in our weekly meetings about causal inference and really trying to push, let's think about this from the target trial framework and causal roadmap. And also my collaborators at UPMC who are focused in this area, there's a lot of interest. I've gotten them to come on as stakeholders in my projects. And also in some of the biomarker studies where we're looking at different things related to chronic kidney disease. And I also work with National Institute for Occupational Safety and Health, looking at helping them with analytics on their related to COVID. They certify respirators. They're the only source nationally that certifies respirators. So they're very interested in that too. So yeah, I think there's been a lot of increased interest. I'm not sure how much is COVID and how much is the expansion of EHR systems and clinical data and research networks. I think that's a big part of it.
Yeah, I've heard folks who have learned the topic propensity score, and they're like, oh, we can do this and we'll just fix it with propensity scores. So that's been one that's buzzing around my head from clinicians lately. I do have a question that's come in from Sandra Stinnett, and I think this is one that many of us are thinking. The tools and courses that you are showing, are these accessible outside of Pitt?
Yes, they're completely publicly available. They're in Google Drive. So if I just go here, this is exactly how it would look for you from anywhere outside of Pitt. So this is a Pitt website created by our Office of Communication. I wanted to have something where we had some help and it wasn't, I was not sure what to do. So I said to my instructional designer, Chris, I'm like, figure out what to do, what's the best way. And what she came up with was working with our Office Communication. But it is an outside website. And you can go, the other thing is I'll mention one of our collaborations is with the Compare Effectiveness Research Center here at Pitt. So this link also goes to their website, which is a Pitt website, but outside accessible. And then they have, if you wanted to focus specifically, it's a little slow coming up, but if you wanted to focus specifically on writing a proposal and compare effectiveness, they have a link to getting funding. And they put, it's not coming up here for some reason, but they put in $signs was my idea, catch people's view. So it links back to some of our resources and links to more general things like stakeholder engagement, things like that. So these are all publicly accessible from anywhere, yes.
Excellent. I know that we're coming up to the end of the hour. I would like to ask sort of a question non-specific to causal modeling, but is someone who's interested in redesigning how I interface with the biostats and epidemiology program for our clinicians. How have you seen folks receiving these types of workbooks and online do-it-yourself self-paced training?
So they've been very well received. As I mentioned, I've been teaching the in-person, or formerly known as the in-person CER course for the last 10 or 11 years. And we've now basically moved to a colleague, and we want to write a paper on this soon. She came up with the term templatizing the course. We're still not sure if that's a real word, but basically first Tuesday, we introduce the course. Tuesday to Thursday, they watch the videos. It's kept to 1 hour to 2 hours. From Thursday to Tuesday, they go through the workbook, which probably takes them more like 4 to 5 hours. We come back in the next Tuesday. I look back on the subject matter with kind of a chance for questions broad oversight. And then I also look forward to the next week and say, here's what you're going to do Tuesday to Thursday. They watch the videos. We then come in Thursday, they go into small groups, and we do peer feedback. So they just, each time we set up with about a couple of people, go over a half-hour period. I take 18 people, I divide them 3 ways into 3 small groups. A couple of people each week say, this is what I'd like to talk about. And I've gotten very positive feedback. Last year, other than I had one, there was
there's always
love
one.
it, it's pretty good. Darn, I really hate everything you did. Other than an outline, I really hate it. It was definitely the most positive evaluation. So I think it's well received. And my colleagues who are doing this is really, they're a big part of their, their research have said they found invaluable. So.
Excellent. Well, thank you again, Doug. We've reached the top of the hour. I'd like to remind folks who are on the phone that this session has been recorded and we will be posting it on the TSHS website so that folks can review it again in the future. So thank you again. Take care, everybody.
Okay. Thanks, everyone.